Welcome to episode 13 of CipherVibe's end-to-end cloud security architecture course. Data classification and discovery make the organization's most sensitive information visible enough to protect. They connect technical stores to business meaning, owners, retention needs, and handling expectations. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. Classification drives encryption, access policy, DLP, logging, regulatory mapping, and incident priority. Without reliable data context, cloud controls often treat a public marketing file and a regulated record as if they create the same risk. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is define a usable taxonomy. Create a small taxonomy that people and systems can apply consistently, such as public, internal, confidential, and regulated or restricted. For each level, define handling, sharing, retention, encryption, access, and incident requirements with accountable data owners. The second building block is discover data across stores. Use discovery tools to inspect object storage, databases, file shares, SaaS exports, logs, and data pipelines for patterns and contextual clues. Tune detection, validate high-impact findings, and track which stores are covered so absence of findings is not mistaken for absence of data. The third building block is apply tags and labels at creation. Apply metadata through creation workflows, data catalogs, schemas, and infrastructure templates whenever possible. Define inheritance, correction, and exception rules. A label that is easy to remove, never checked, or disconnected from enforcement will not create meaningful protection. The fourth building block is manage data through its lifecycle. Connect each class to retention, archival, legal hold, deletion, backup, and replica requirements. Include derived data, analytics copies, exports, and disaster recovery stores because sensitive data often spreads beyond its original system long before an investigation begins. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. The reference pattern establishes a business-owned taxonomy, scans priority stores, applies trusted metadata at creation, and uses those labels to drive handling and lifecycle policy across primary and copied data. Implement this layer in a sequence that preserves evidence and limits blast radius. First, define the smallest workable classification scheme. Second, identify priority stores and data owners. Third, run discovery with validation and false positive tuning. Fourth, integrate tags into templates and data creation paths. Fifth, map each class to retention, encryption, and sharing requirements. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, creating labels that have no technical or business consequence. Second, scanning only one storage type while data moves through exports and logs. Third, assuming automated pattern detection is perfectly accurate. Fourth, ignoring backups, replicas, and analytics copies in lifecycle policy. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, measure high-risk store coverage and classification completeness. Second, test a sensitive data finding and owner notification path. Third, audit label changes, lifecycle enforcement, and exception ownership. Fourth, verify deletion and retention behavior using safe representative data. Test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, create a classification plan for a fictional customer platform that stores support tickets, payment tokens, and product analytics. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that data classification and discovery becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.